All right, lesson 6. Let's go ahead and look at our examples now. Here's our first set of examples, 1 through 5. So here is a graph representing an exponential growth function per year. You can see based on the shape of the graph that it is definitely a exponential growth situation. So number 1. Find the growth factor per 2 years. So the growth factor per 2 years. Okay. Hint: to find the growth factor, divide any y value by its previous value. So per 2 years, we're going to use this point right here and this point right here. Notice it goes from 4 to 9, so it's definitely increasing. So to figure out the growth factor, we're going to take the value of 9 and divide it by the previous value of 4. So you should be able to do this in your head, but if you can't, we can, again, like I show you, you can do it on a calculator. So my growth factor in this case is going to be 2.25. So that is the answer to number 1, 2.25. Okay. Number 2, write the equation of the function per 2 years. So let's fill in our formula here. My initial value, what is my initial value of the function? Well, at x equals 0, we start at 4. So 4 is the initial value. Okay. And then we already said our growth factor is 2.25. So my equation is 2.4 times 2.25 to the power of x. Okay. But just remember, okay, and we've seen in our past couple lessons, x here is the number of 2-year time periods. Okay, so x is the number of 2-year time periods. All right. Number 3, write an expression for the value of the function after 1 year. So in other words, we first have to figure out what value are we going to plug in for x here. All right, so to do that, I have to figure out how many 2-year time periods we're talking about. So here we go. So we want 1 year. 1 year, okay? What that means is to convert it to 1 year is actually 1/2 of a 2-year time period, right? Okay, that's what I was trying to say. I got myself a little tongue-tied there. So 1 year is 1/2 of a 2-year time period, which means I'm going to plug in x equals 1/2 into the equation. Okay, 1 year, 1 divided by 2 is 1/2. So the expression is going to be 4 times 2.25 to the power of 1/2. Okay, that's the answer to number 3. Number 4, write an expression for the value of the function after 5 years. So we're going to do the same thing. 5 years. All right. 5 years. So 5 years, I have to convert that to 2-year time periods, which means I need to divide it by 2. So 5 divided by 2 is 2.5. Okay. So 5 years is the same as 2.5 2-year time periods. All right. 5 divided by 2 is 2. So I'm going to do the same thing. that I did in number 3, except I'm going to plug in x equals 5 halves or x equals 2.5. Either one works. Okay, and I could put that in a calculator if need be. Okay. Write an equation for the value of the function per year. So the key is we had to convert years to 2-year time periods. So notice in number 3, for 1 year, notice I took that and I divided it by 2. Same thing with number 4. I took 5 years and divided that by 2. So to figure out the the value after 1 year, I have to take the number of years and divide it by 2, since my original growth factor was per 2 years. So what is that going to look like? That's going to look like this: 4 times 2.25. Okay, and I'm going to use t as the number of years. So t over 2. Okay, so to figure out what my x value is, what my exponent is, I have to take the number of years and divide it by 2. So that right there that right there is my equation for the value of the function per year. And if you check that against number 3 and number 4, it works out just fine. Okay, let's go ahead and look at the next group of examples. So same thing we just did, except now we're going to look at exponential decay. Okay, so here's a graph representing an exponential decay function, okay, per year. Find the decay factor per half year. So notice my x value goes from 0 to a half. So my decay factor, my original decay factor, is going to be per half year. So decay factor per half year. Okay. And notice it goes from 10 to 5. So going from 10 to 5 means it's halving. So my decay factor per half year is 0.5, a half. Okay. Number 7, write the equation of the function per half year. So if we fill in our formula, okay, what's our initial value? My initial value is 10. So 10 times, we already said our decay factor is a half to the power of x. So that is right there. 10 times a half to the power of x is the answer to number 7. The key thing to realize, is x is the number of half years. The number of half years, not the number of years. Okay? That's important to realize when we talk about number 8. Okay? Number 8, write an expression for the value of the function after 1 year. So 1 year is the same as 2 half years. Okay? Do we agree with that? Okay? Is 1 year the same as 2 half years? And the answer is yes, of course it is. So I'm going to plug in for number 8, I need to plug in x equals 2. Okay? So my expression, okay, write the expression for the value of the function after 1 year is going to be 10 times a half, and my exponent here is going to be 2, because 1 year is 2 half years. So there's your answer to number 8. Number 9, write an expression for the value of the function after 4 years. So same thing, 4 years is how many half years? So 4 years is the same as 8 half years, right? 8 half-year time periods is equal to 4 years, which means I need to plug in x equals 8. So I'm going to do the same thing I just did, 10 times a half, but instead of to the power of 2, it's going to be to the power of 8. 4 years is the same as 8 half years. So 10 times 0.5 to the power of 8. Okay. Number 10, write an equation for the value of the function per year. Okay. The key is for 1 year, we plugged in x equals 2. For 4 years, we plugged in x equals 8, which means we have to take the number of years and double it to figure out the number of half-year time periods. So my equation, and again, I'm going to use t again, is going to be 10 times a half to the power of 2 times t. Okay? Because if we had 1 year in number 8 and I plug in t equals 1, I end up with an exponent of 2. 2 times 1 is 2. Number 9, when I wanted to find the value after 4 years, if I plug in t equals 4, then I end up with an exponent of 8. So I converted it from a equation per 2 years, equation per half year up here, to an equation per year down here. So this right here is the equation per year. And you'll see something similar to this on your cool down tonight.